Hello friends, uh, let us start with another topic that is about linear block codes. Here are the contents. We'll see what you mean by linear block codes, what you mean by generator matrix, how to encode such codes, and why we need to use the parity check matrix. Some hardware circuit implementation of such codes, we call it as syndrome and error detection encoding circuits. Minimum distance, one of the important parameters through which we can find out the efficiency of the code, followed by some advantage and disadvantage. See here, the purpose of error control coding is using certain set of codes, we can detect the errors, that is the transmission errors. Certain codes have the capability even to correct the errors. One such code is the linear block code. It is certain coding technique where a set of code vectors what we generate using certain procedure, we'll see it very soon. Once we generate the code vectors, and those codes have very powerful technique through which we can detect the errors that normally occur during the transit in any communication system. There are two different types of mechanisms in forming the code. The one is the block coding, one more is the convolution coding. So linear block code is the block coding method. Here what we'll do, the encoder, it will receive the message bits m and it will add the k number of information bits, and it generates the code word C in such a way that n is bigger than k. There are possibly 2 raised to k number of code words possible. If there are 3 bits we use for a k, then 8 code words will get it. And the encoder generates a block of coded information from the k information bits. That is what we call it as a nk block codes. The coded bits are also called as code words. Why linear means it was using mod to sum of code. So it is linear. A n code word symbols can take 2 raised to n possible values. From that we select 2 raised to k code words to form the code. A block code is said to be useful when there is no one mapping between message m and its code word C as shown above. We'll see it later. Again, to generate the linear block codes, we need some two matrices. One is the generator matrix, one more is the parity check matrix. This is the generator matrix. We'll define in matrix form like this. The elements of generator matrix are G11, G12, so on up to G1n. Second row G21, G22, so on up to G2n. Last row GKN, GK2, so on up to GKn. All code words are a linear combinations of code vectors. It will be defined as G1, G2, G3. For a linear code, there exists a k by an n generator matrix such that the code vector C, it is a multiplication of m into a g. So m we can sometimes call it as a d also, a data, and g is a generator matrix. So C is equal to dg or mg, where C is equal to C1, C2, so on up to Cn, and the code vectors at m are the message vector. The block codes in a systematic form. See, in this form, the code word consists of n minus k parity check bits followed by k bits of message. The structure of the code word in systematic form is, this is the message part, that is a k, then n minus k bits will be inserted as a redundant bits. Always we see that sometimes deliberately will add some information bits, we call it as a parity bits. At the other side we can easily find out whether the error occurred or not. So one best example is the parity, check some bits and all. Next part is the rate of the efficiency of the code is same k by n. We find out using ratio of k by n. Generator matrix we can obtain with a combination of identity matrix I of the order k. If the k is 3, then there is an identity matrix of 3 into 3 followed by a parity matrix. So code word can be generated using mg or dg. Okay, where m is the message part and g is the generator part, whereas p is the parity part. Take one simple example. We need to generate a simple linear block codes of length 74, where this 7 indicates the code word length, where 4 indicates the message bits. We call it as a NK, where K is 4, that is the length of the message is 4, and code word N is 7. M is equal to 1110. This is suppose one message. Since K is 4, we can take the information bits from all 4 zeros to all 4 ones. So 1110 is one among that 16 combination, and G is G0, G1, G2, G3. It's a generator matrix. How we can define this? You know that it's an IK where K is 4, so identity matrix of order 4. Okay. Next, I kept it here, identity matrix 1 0 0 0 1 0 0 0 0 1 0 0 0 1. Whereas this part is the parity 1 1 0 0 1 1 1 1 1 0 is the parity matrix. It varies, and the entire code vector depends on the parity matrix. This is the given parity matrix. So C is equal to, we all know that previously it is an mg or a dg. So m1 g1 plus m2 g2 plus m3 g3 plus m4 g4. You have this matrix get ready, you can just multiply it, where m is row and this column. So we'll finally get the code vector of length 7. Just multiply it. 1110, you multiply with this, next this into this, can multiply, we will get the code vectors. That is what it is. 1 multiplied g1 plus m2 is 1 again, so g2, m3 is 1 again, it is g3 multiply with g3, next g4. This is the code vector. Finally we can get it. Just the row into column multiplication with the d and g respectively. See, another method is let's consider m is equal to m1 to m4 and c is equal to c1 to c7. C is equal to mg. This m, and this is what? G. By matrix multiplication, we can obtain the c1. The first code vector c1 is equal to what? m1 plus m3 plus m4. The first case, because second bit is 0, so m2 into 0 is 0. So m1, m3, m4 exist. So I have written here. Similarly, second m1, m2, m3, m4 is 0. So m1, m2, m3. Similarly, code vector c is equal to, first one is 0, then it is m2, m3, m4, m2, m3, m4. Like that, you can build these equations. Now using this equation, just substitute the binary bits readily. The c1, c2, c3, so on up to c7 are readily available for any message bits. Suppose you can take any 4 bits here, directly you can substitute here. I can get it c1, c2 up to c7. So the code word corresponding to the message 1110 is 1110 means this is m1, m2, m3. m4 is 0. Substitute here, you will get a code vector of length 7. This is how we can generate the code vectors in the linear block codes, where the k information bits will be there, n minus k redundant information has to be added, and will generate a generator matrix using an identity followed by a parity matrix. For a given parity, there exists a code vector. If parity changes, again the code will change. So C is equal to dg is the best way of multiplication of the matrix, or else by this method to generate the code vectors. We will see some of the advantages of such code vectors in the next topic.